Oh, oh, okay. Yeah, maybe we have the same internet service provider. I don't know what we have, so maybe because of that. Wow, that's taking forever. Okay. So students in the Zoom classroom, you can just be patient. That would be wonderful. Okay. Now, begin with empirical rule. Okay, so yesterday we started working on measure of position, right? We have three things to cover in this module. Measure of centers, we completed that. That's mean, median, and mode centers. And the next one we did was the measure of variation. In measure, we work on range and standard deviation, right? And the last one that we have started is the measure of position. Measure of position, we do three: z-score, and then quartiles, and the last one will be able to cover up to percentile. I mean, up to quartiles, percentile. Okay. So we already did what is z-score, and we look at one of the applications theorem. Now, today we are starting with the second application of the z-score. That we have seen that in Chebyshev's theorem, we can use the distribution, right? The distribution can be skewed or normal. We can use the Chebyshev's theorem. Chebyshev's theorem, there was one restriction, that is, you can use Chebyshev's theorem than one. But this one, empirical rule is a little different. So in the distribution must be normal, okay? Your distribution must be normal. You can distribution regardless of shape. However, when the distribution is bell-shaped, the empirical rule. The second difference that you can see between the theorem. In Chebyshev's theorem, you can calculate the minimum percentage, like that formula, if you remember from the minus 1 over k squared times 100%, right? That gives the minimum percentage of the data. But Chebyshev's theorem, it gives the approximate amount of data within deviation. So for example, in this diagram, if you look here, in the middle, we have standard deviation up. We're pointing with my mouse here. Okay, one standard deviation up and one standard deviation. You'll have approximately 68% data. If we go 2 standard deviation up and 2 standard deviation down, you can in 2 standard deviation of the is approximately 95%. And then if we go 3 standard deviation down, we have almost everything. We can capture almost every standard deviation. We have all 100%, right? 99.7% data. So give you the idea about the amount of data within one standard deviation as 68%, 95%, 99.7, 68, 95, 99.7 rule. You need to remember these numbers, right? Within one standard deviation about the mean, you have 68% data. About the mean, you have 95% data. And within 3 standard deviation about the mean, you have 90 data. Okay. Now we are going to look at a little more sense. So here we go. I changed this. Changing there, kind of slow. Look at that. Okay, there we go. On here, monthly Excel energy bill in Aurora, Colorado are distributed normally with $50. So that is the general information about the, okay, average $250, and then this, they say that the distribution is normal. So what we can do is we can sketch that normal distribution and try. So let's do that. Let's try to draw a normal distribution. Okay, so that is the normal distribution with the mean of and standard deviation 50. Meaning of that is your mean is 50. Mean 250 is in the middle here. Okay, now we can go one standard deviation up and one standard deviation. So if I go one standard deviation up, it is 250 plus 50 because the standard deviation is 100. And then on the other side, 250, 200. So one time, look at the screen and try to understand. So here in the middle, you have the mean, which is 2 is 50. So if I go one standard deviation up, that will be 300. And when I go one standard deviation down, one standard deviation. And you know that the amount of data within one standard deviation 68%, right? So if you look at the first question, what percent of monthly bills are in the range 200 to 300? How much is there? 68%, right? So the answer for the first part is 68%. 68% of bills in the range of $100 to $300. You know from the empirical, within one standard deviation, you have 68%. That's why within one standard deviation, you have 68% of the bill. That is by the, okay. Any question on first part? If you have question, you can unmute yourself and ask. Is there a question there? Off. OF off. That's my fancy off. See, I write instant, right? Okay, now let's. The second one involves little more work. The question here is, what is the probability later on? But let's find the probability that a randomly chosen monthly bill is 150. Let's complete this diagram. We went up to one standard deviation. Let's go to two standard deviation and see what we get. Okay. Students in the virtual classroom, please unmute yourself and ask if you have any question, okay? So that I understand what you're trying to say. Okay, let's go to 2 standard deviation. If you go 2 standard deviation, you can see that here is 250. When you go 1 standard deviation, 300. If you go 2 standard deviation, then it will be 350, right? Because the standard deviation is 50, meaning you are continuously adding 50 there. Similarly, if I go 2 standard deviation down, if I go 2 standard deviation down, you can see here is 250, then that becomes 200. When I go one more time, that is 150. Okay, so now the question here is, what is the probability that randomly chosen monthly bill is 150 or less? This is 150. We want the bill amount or percentage that is less than 150. That means basically we want this, that much. Over there, how much is there? We need to find. Okay. And what we know is this distribution is a normal distribution or symmetric distribution. So the amount of data that is here, where I have said it here, is equal to the amount of data on this side. That is by symmetry. Okay. By symmetry, the data on this side and data on this side, the area on two tails must be equal. Now, can anyone tell me how much data is between 150 and 350? How much data is between 150 and 350? How much is here in the middle? You can use the empirical rule. How much? How many percent? 95%. That's right. Because this is the mean. We went 2 standard deviation up and 2 standard deviation down. So by empirical rule, within 2 standard deviation, you have 95% data. So I can write 95 in the middle. See, 95% data is here in the middle. So how much data is remaining now? 5%. That's right. So that remaining 5% is divided on two tails equally. 2.5% each. That's right. 2.5% here and 2.5% there. So what you need to do is you need to clearly label the diagram like this and show everything. So now what you know is the amount of bill that is less than 150 is 2.5%. So I can write like this: percentage of bill bills less than $150 is 2.5%. Remember, this is in percentage. But the question is not asking for percentage. Question is asking for probability. So it is easy to change percentage to probability. That is basically you are changing the percentage to decimal. So we can write like this. Let me write using a standard notation. Probability P, okay, probability that the monthly bill X, it can be any amount along the x-axis. So X, because these are different bill values. Monthly bill X is 150 or less, means less than or equal to 150 is equal to, see, the probability is 2.5. Probability is 2.5. If you want, I mean, percentage is 2.5. If you want to change it to probability, divide it by 100. 2.5% means 2.5 over 100 per 100. And when you divide that, you'll get 0.025. So the probability that the monthly bill amount is less than or equal to 150 is 0.025. That is how you need to find the probability. Remember, to find the probability, first you have to find the percentage, divide by 100 to get the decimal, because percentages, I mean, the probabilities are always in decimal. That's why we need to divide that. Okay, if you have any question on this, you can ask me now. Students in the virtual classroom, if you have a question, please unmute yourself. I need to hear your voice. I'm waiting so that I may hear something, right?
I'm good.
I'm not just waiting for the students in the virtual classroom. I'm also waiting for you guys. If you have anything.
So when you're asking for the probability is not a percent.
Correct. So if it is asking for the probability, it is the decimal. So you find the percentage first and change it to decimal. That's what you have to do. Okay, so with this, we are done with the first measure of position, that is the Z-score. We did the Z-score and we look at two applications, right? We look at the Chebyshev's theorem and empirical rule. Now we are going to move on to second measure of position, and that is called the quartiles. So when we say quartiles, these are the numbers that divides the entire data into 4 equal parts. Let me try to write something here and explain it. Let's say when the data is arranged, you have the data from minimum value. Okay, when data is arranged, we'll have data from minimum to maximum. Okay. Like that, right? When you arrange the data, say, for example, when you're calculating the median, if you remember, we arrange the data, right? So just like that, if we arrange the data, we'll have minimum this side, we'll have maximum there. So that's how we can arrange the data. Now, you already know what is the value that we find in the middle. What is the value that is exactly in the middle? Median. So we can find median. Median is the value that is exactly in the middle. MED, median. And you can see that this median divides the entire data into two parts, 50% below that and 50% above that, right? 50% data is below the median and 50% data is above the median. Now, if you repeat the process, say, for example, if you want to look at the data from minimum to median, look at the screen carefully. If you want to look at the data from minimum to median and find the middle value here, that middle value will lie somewhere there. See, we can find a value here in the middle that divides the lower 50% into 25%, 25%. 25% here and 25% here. And you can do the same thing for this upper 50%. If you divide that into two equal parts like that, okay, you'll have 25% data here, 25% data here. 25%, 25%. So you can see that, now if you look at the screen carefully, you can see that this number that will be here, where I'm pointing right now with this first dot, this one number, here is the second number in the middle, and here is the third number in the middle. These three numbers divide the entire data into 4 equal parts, 25% here, 25% here, 25% here, and 25% here, into 4 quarters, right? That is why these three numbers, they are called the quartiles. So this one is called the lower quartile or first quartile Q1. One in the middle is the second quartile, also known as median. And then this one is the third quartile Q3. So quartiles are the numbers, one more time, quartiles are the numbers that divides the data into 4 equal parts. Okay, quartiles are the numbers that divides the data into 4 equal parts. In order to find the quartiles, we can use calculator and find this value. That's the easy way. Okay, you can use calculator and find the value of the quartiles. Now, once you know the quartiles, there are a couple of things that we need to know here. One is called the interquartile range. You may be asked to find IQR later on. What is interquartile range? interquartile range is the difference between the third and the first quartile. Interquartile range is Q3 minus Q1. Okay, interquartile range is the difference between the third and the first quartile. You'll also hear something like mid quartile. Mid quartile is the average of Q3 and Q1. Okay, mid quartile is Q3 plus Q1 divided by 2. So you'll see that in the examples, you'll be asked to find something like that. IQR and mid quartile. Okay, we also need to know one more thing here. We calculate these quartiles because it's not just because we can divide the data into 4 equal parts, but these quartiles can help you to determine if there are any outliers in the given data set. When I say outlier, if the data value is significantly smaller than the majority of the data values or significantly larger than other data values, we call them outlier. And we can find outlier using the concept of quartiles. So how is that possible? Let's see. Let's quickly write the definition of the outliers over here. Outliers are the values greater than this one, Q3 plus 1.5 times IQR, or smaller than this value, Q1 minus 1.5 times IQR. So what I'm saying is, if you want to find the outlier, then what you have to do is you have to find Q3 plus 1.5 times IQR. This is the boundary. If you see anything more than that, that is the outlier. So this one, Q3 plus 1.5 IQR, that is your upper boundary for IQR. Upper boundary, UB. And similarly, this one. If the data value is smaller than this, that's also the outlier. So we call this one lower boundary. Okay, any value greater than Q3 plus 1.5 times IQR, or the value less than Q1 minus 1.5 times IQR, they are called the outliers. And one last thing that you want to know from this slide, see, when we find, if you go back to this diagram here, look at that. When we find these 3 values, Q1, Q2, Q3, these are 3 values in the middle. Here we have the minimum, here we have the maximum. So if we add those two, we have 5 values there. And these 5 values are called the 5-number summary for the data. 5-number summary. So if you're asked to find 5-number summary in the mastery exercise, you are looking for these 5 values: minimum, first quartile, second quartile or median, third quartile, and the maximum value. These are the 5-number summary.
What does the UB and LB mean?
This is UB means upper boundary, and LB means lower boundary. Upper boundary and lower boundary. So these are the upper and lower boundary for the outliers. Okay, any value greater than upper boundary is an outlier. Any value less than lower boundary is an outlier. Okay, if you have any question on this so far, you can ask me now. If not, I'm going to show you how we can find the quartiles, and also those minimum and maximum are 5-number summary using the calculator. Okay, we'll focus on calculator here. So here is the example: collision coverage insurance against physical damage paid in dollar by an insurance company for a sample of 18 collisions are listed here. So I have the 18 data values there. You can see this is saying we have really bad problem with the internet today. So they are saying that. Okay, I can connect it. Give me a second, students in the virtual classroom. My computer is saying something. They said it is not working. Okay. If they say that, maybe they're right. Okay. Anyway, so let's see how we can find the 3 quartiles using our calculator. So I'll not be able to share my calculator from my computer because of the internet. So I'll try to share a calculator app that I have on my iPad. Let's see, which is similar to our TI-84 calculator. Okay. Now what you need to do is, first of all, from that example, we need to enter the data in the calculator. So the way we do that is we go to stat, where I'm pointing right now, as you can see, where it says STAT stat. Click on that and then enter. Stat and then enter. So you'll see that your cursor is under L1 in your calculator. So over there, you start entering the data. So 180. See, 180. 180. Now, please enter all the data values. 189, 370, 618, 735. Old man will go slow. I know you will be able to do it fast. That's perfectly fine. 802, 1105, 1114. See, old man has to read all those numbers. 65, 1953, 2332, 2336, 3461, 4668, and then we have 6751, 9908, 10034, 21147. Okay, old man is done, right? Now, what we need to do is, in order to find those 5 numbers, Q1, Q2, Q3, minimum and maximum, what we need to do is, we need to go to this stat again. You press that stat, and then in the second tab there, you'll see calculate. You go to calculate. Okay. You go to calculate, and the first one, which is already highlighted for you, that's where we are going. One variable stat. So just enter, and you'll see that you have the values in L1. Your data is in the list 1. There is no frequency. In your calculator down there, there is calculate. Check it. Do you have calculate there? I don't have it here. So go to that calculate, move down with that down arrow, go to that calculate, and then enter. Did you do that? And then maybe in your calculator, what you are seeing is, you are seeing up to here. Do you see minimum there? But there is an arrow by the side of that in your calculator, where I'm pointing right now. Here, there is a downward facing arrow in your calculator, right, at the end. So what you'll do is, you press this one a little bit. So you'll pop up all these values. Okay, if you press that downward arrow, you'll see all these values. See, we have the minimum of 180 in that data. First quartile is 735. median is 1559, third quartile is 4668, and the maximum is 21147. Is that right? Did I enter the data wrong? What is your third quartile, by the way?
4663.
That's correct. Okay, okay, that's perfectly fine. Yeah.
When it's saying median equals 1559, is that quarter two?
Yes, median is same as the second quartile. Yeah. Mhm. Okay, so you can write those values now in your note catcher. So let's write it down.
Way to do this without.
Yeah, you have to arrange the data and then you have to look for the middle value. It is very tedious.
Okay.
So we use the calculator. Yeah, we can do it. But technically, when you have a very long data, in real world, you have so much to do, right? You may have thousands of pieces of data. So when you'll be able to arrange and then find the middle value, it takes time. So we use calculator. So I'm writing.
The exams, we have where we have to do it without.
No. So using TI-84 calculator, we have Q1, because we just want Q1, Q2, Q3 here. Q1 is equal to 735. Q2, which is also the median, is equal to how much? 59, right? And Q3 is equal to 4668. So you can see that it's fairly easy. All you need to do is plug in all the values in the calculator and get these 3 things or 5 things, whatever is required. If you're asked to find the 5 number summary, you also need to include the minimum and maximum. Okay, any question on this? Okay, if you have no question, that is perfect. Let's move on to next one. So now you know how to use the calculator and find these values. So in the upcoming examples, I'll ask you to find the values yourself, okay? So here is the next example. So in this one, for the following set of data, we are asked to find the interquartile range and mid-quartile. So you already know what is interquartile range. Interquartile range IQR is Q3 minus Q1, and mid-quartile MQ is Q3 plus Q1 divided by 2. So you can clearly see that to find the interquartile range, you need Q1 and Q3. And also to find the mid-quartile, you need Q1 and Q3. So please use your calculator and tell me what are Q1 and Q3. Okay, use your calculator. Tell me what you get. I'll wait for a little bit. Okay, what do you get? What is Q1 equal to? Q1 equal to how much? When you enter all this data and find that, it should be 51.5. Okay, make sure you check it. It should be 51.5 and Q3 should be.
When we go back to the table, how do we do it?
Okay, that's a good question. So when you, okay, in your calculator, mine is different here. in order to clear, let's see, when we go to start and enter there, what you have to do is, I think in your calculator, it has highlighted somewhere there in the over here, right? Highlight means it is in black color there. So use this arrow to move that all the way to the top. That's one way, but hold on for a second. If you move the down, if you click the down arrow, if you just click the down arrow, where will that highlight go? Just check it. If you press the down arrow, the highlight will go up here, right? Highlight means it will be in black. Everybody try that. And then once it is here, move one more step up using this up arrow so that this L1 is selected. Select L1, then press clear. And then move that down arrow, click that down arrow. Everything is cleared, then you can enter the data. So one more time, to clear the data under list one, you have to highlight this list one, don't delete. If you delete, L1 will go away. Okay, don't delete. You don't want to delete things from calculator. You highlight L1, clear it, and then press down arrow. I can see that some of you don't have calculator with you. If you don't practice this in class, I'll not be surprised if you get lower score in the exam because of not using the calculator. It's not easy, right? You have to follow a lot of steps there. Okay, wonderful. Now let's go back to that. So you got those values. So after you got those values, the first thing we want to find is the interquartile range IQR, which is equal to Q3 minus Q1, which is equal to 58.5 is Q3 and Q1 is 51.5. That is equal to 7. So IQR, interquartile range, is equal to 7. And then the next one is the mid quartile. Mid quartile is equal to Q3 plus Q1 divided by 2. Q3 is 58.5 plus Q1 is 51.5. You divide that by 2, that's equal to 110 divided by 2 or 55. 58.5 plus 51.5 is 110. And when you divide it by 2, that's a 55. If you have a question on this, you can ask me. If not, finish up your writing there. Do you want to bring your calculator here or come with the calculator? Do you have your data entered in the calculator? Okay, come here. I can definitely help you with that. So let's see. So you have the data entered, right? Which is this one? Okay, yes. Okay, so what you have to do is you go to stat, then go to calculate, because you need the calculated value, right? So you go to calculate, and then this is already selected, enter. And then go to calculate now.
Okay.
So you'll see those values, right? Q1 is 51.5, Q3 is 58.5.
Okay, thank you.
Yeah. And for all of you, when you're doing the homework, what I've done is in the example problems that I've solved for you, do you know where to find them? In the announcement, right? I told you on the first week. If you go to the announcement, there is a link. Okay, there is a link if you need help with the mastery exercise. And if you watch those videos, you need help with any of the problem. When you watch there, I also have incorporated the calculator screen there so that you can see how to use the calculator and solve these problems. Okay, so I encourage all of you to watch those videos when you're doing these mastery exercises. You don't need to go to tutoring lab for mastery exercises because I've already solved similar problems and then I've created the video. So you don't have to run to the tutoring, ask for anyone. watch the video. You can pause me, you can forward me, you can pull me back, whatever you want to do. But watch that and solve the problems. Okay? Everything is there, including how to use calculator. Okay, now let's move on to next example. Remember, when I was talking about quartiles before, I told you that quartiles can help you to find the outliers, right? So in next problem, we are going to learn how to find the outliers. And if you remember, in order to find the outliers, let me go back here. In order to find the outliers, what you need is, you need the upper boundary, which is Q3 plus 1.5 IQR, and you need the lower boundary, which is Q1 minus 1.5 IQR. So you know how to find the IQR. IQR is Q3 minus Q1. So what we need is, from the given data, you have to find Q1 and Q3, and then you find the lower and upper boundary. If you see anything below the lower boundary or anything above the upper boundary, they are the outliers. Okay, so that is exactly what we are doing here. So for this example, please plug in the data in your calculator and find Q1 and Q3 first. What's your Q1? If you got it already. Students in Zoom classroom, if you want to say what is Q1, unmute yourself and you can tell.
9,
9, okay. And what is Q3?
20.
20. That is correct. So now, once we have Q1 and Q3, we can find IQR. So IQR equal to how much? How do we find IQR? It is Q3 minus Q1. That means that is 20 minus 9. That is equal to how much? 11, right? Q3 minus Q1, meaning 20 minus 9. That is 11. So now let's find the lower boundary for the outlier. Lower boundary is Q1 minus 1.5 IQR, right? That's the lower boundary. If there is anything below this value, they are outlier. So Q1 is 9. 9 minus 1.5 times IQR is 11. So if you type this in your calculator, 9 minus 1.5 times 11, that is equal to negative 7.5. Make sure you check it. I got negative 7.5. And you look at the data set here. Is there anything below negative 7.5 here? No, right? That means there are no outliers in the lower end. Now let's check the upper end. You know your upper boundary is Q3 plus 1.5 times IQR. So upper boundary is 20 plus 1.5 times IQR is 11. So you can see that 20 plus 1.5 times 11 is 36.5. Check it. You can type that in your calculator, 36.5. Now, once you have that, you have to look at the given data set. Are there any data values more than 36.5 here? What is that? 50, right? 50 is more than 36.5. That means 50 is an outlier. Okay? So we'll write that answer here. Since 50 is more than 36.5, it is an outlier. Okay? Since 50 is more than 36.5, that is an outlier. That is how you can find the outliers. You can use the quartiles, right? You can use the quartiles to find the outliers in the given data set. If you have a question on this, feel free to ask. It is quite straightforward. All you need to do is find those values, plug into the formulas, and see whether any data value is below or above that. Okay, now we have one last thing from these quartiles. That is, we can present the data. We talk about the presentation of data in module 2, right? We can present the data using several different ways. We talk about histogram there. We talk about bar diagram there. We talk about stem and leaf plot, if you remember, right? We talk about pie chart. These are all the presentation of data. We can also present the data using the quartiles by making box plot. So the next one that we are going to look here is we are going to make box plot to present the data. So basically, while making the box plot, what we do is I intentionally left something down here, and we are going to add that now. What we do is we draw a line here. We draw a horizontal line to represent the data. We draw a horizontal line to represent the data. Maybe the data values are like 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, and so on. So we draw this scale. Okay, we draw the scale. Then what we do is, using our calculator, we find the 5-number summary. That is, you plug in the data in your calculator, you'll be able to get Q1, Q2, Q3, and also the minimum and maximum from the calculator, right? So what we do is we draw a box based on this scale. We take any point above that. We draw the box going from first quartile to third quartile. You can see that we can draw a box going from first quartile up to third quartile. Remember, this box must be above that line. Here is the line. It should be above that. You draw the box. That is the first thing. And what we also do is we also put median. Where is the median? You find where is the median, and over there you draw the vertical line. That is the median. So you have Q1, median, and Q3 here. And then from the middle of the box on the left side, look here. From the middle of the box on the left side to the minimum, we draw the whisker. That box, that was the box in the middle, we draw the whisker. We do the same thing on the other side. From the middle of the box on the right side, all the way to the maximum, we draw the whisker. So this diagram that is created here, this is called the box and whisker plot, or simply box plot. Okay? And this box plot is very powerful. Like we can, here is the median, we can easily plot where is the mean. By looking at the data, you can also plot the mean. If the mean is on the left, the data is left skewed. If the mean is on the right, the data is right skewed. So we can also use the box plot to, see whether the data is skewed or normal. If the mean is right here in the middle, then it is a normal distribution. So let's learn how to create a box plot. You may be asked to create a box plot in the quiz. So if you are asked to draw the box plot in the quiz, you'll have a graph-like thingy given there, and you'll have tools to draw the box because your quizzes will be online, right? So you'll have tools to draw, and you can use that to draw the box plot, okay? So here is the data. See, construct a box plot for the following data representing the height of 40 students in statistics class. Now, what I want you to do is enter the data in the calculator and find the 5-number summary. In the meantime, I'll just go to restroom and come back. I'll not go with the mic because it catches the sound.
Yeah, I have moments like that too. Oh, what is it? Talking about, I don't know. That's like, it's like, it would be, like, everything. Yeah, and all the movies that you find, I have, you know, and then you do, I'm not seeing any of the announcements. And we're going to. Or we should have seen them. He has a whole YouTube video. Honestly, I love when my teacher. Also teachers, do that. You can do it online. Happens in class. But it was nice to be able to go into that. Oh, you know what? I just found it. Thank you. It's called Namaste Online Tutoring. That's cool. I'm about to subscribe to him. I'm still trying to grasp it. I have to go in my.
Anything fun? No? Okay. So I hope you have your 5 numbers, right? Let me write here. From TI 84 calculator. Tell me what is the minimum value? Minimum is 59. Am I looking at something wrong? You're right. Actually, you are right. I am bad. 50. Minimum is 59. What is Q1? First quartile is how much?
64.
64.5. Second quartile? 66. Very good. Second quartile is same as median, by the way. Third quartile? 70. And maximum is how much? 77. Okay, so we write all those values. Now we have to draw the box plot, right? So what we do is we draw that line to show all the data values. So let's draw that first. Like that. And then here, you want to adjust the data from 59. Look at that. You want to adjust the data from 59 up to 77. So I can probably start somewhere at 55. So that 59 is already there. So I'm going to start at 55, then 60, 65, 70, 75, 80. I think I can just go up to 80 and that's fine because the maximum is 77, right? So that is the first thing you do. You show all the data values along the x-axis. Then the next thing we want is we want to draw the box. And you know that the box will go from Q1 up to Q3. So here Q1 is 64.5. 64.5 means almost 65, right? Almost 65. So right above 65 there, we put a dot. So the box will start from there like that. Okay, box will start from there. It goes up to 70. because Q3 is 70. How tall you want to make the box? I don't care. It is your box. Like that. So you make the box going from Q1, which is 64.5, up to 70. So that is your Q1. There is Q1, there is Q3. Then once you do that, you also need to draw a vertical line in the middle, and that vertical line is for median. So what is the median here? Q2, right? 66. So 65 is here, 66 would be right there. So we have to draw it there. Draw the median there. 66. Okay, I'm just drawing in a different color so that it is visible. Median. So just before 65 is the Q1, just after 65, 66 is the median. Then what you have to do is from the middle of the left side of the box, you should start drawing that whisker. And that whisker goes up to the minimum. Minimum is 59. So 59 is somewhere there. That dot is a 59. Look at that. So you join like that. That is minimum. And then other side, from the right side, you start that whisker and it goes all the way up to maximum. Maximum is 77, which is quite close to 80. So let me show it with the dot there. That is 77. So you connect that to that maximum value. No. That's a good question. Like a whisker, right? Anyways, not just cat, other animals also have that. So yeah. So they are just like the whiskers of the animal. So yeah. I'm like, cat, am I sure? Cat? You can take it, cat, right? Okay. So this diagram is the box and whisker plot. This is one way of, representing the data. And you can see that here is the median, and you can see that this side, on the right-hand side, the whisker is long. That means this data may be skewed to the right. Okay? So data is skewed to the right, that you can clearly see from this data. From the box plot. Okay, this is how we can draw the box plot one more time. In quiz 1, don't be surprised if you see a problem where you have to draw the box plot. Okay. Great. Now we'll do one more example before we call for the day, because we want to finish everything from the quartiles. So here is that last example. Here also we are asked to construct the box plot. Look at that. Construct a box plot of the data set with the values given there. So let's see whether in this one they have not given the data, but they have given the values. So let's see whether they have given all 5 values or not. So what we want is, we want minimum, we want Q1, we want median, we want Q3, and we want maximum. Right? These are the values we want. And let's see if we have all these values given or not. So here they said median is 50. Median is 50. Minimum is 20. Minimum is 20. Q1 is 42. Q1 is 42. They said maximum is 90. Also, they have given IQR is 29. Look at that. IQR is 29. You know what is IQR. If you remember, IQR is Q3 minus Q1. Yes or no? Q3 minus Q1 is IQR. They have not given Q3. They have given IQR. So IQR is 29. Q1 is 42. We don't know Q3. So basically what they are saying is, a number minus 42 is a 29. What number minus 42 is 29? 71?
Yes or no? So that means Q3 must be 71. That missing number must be 71 because the interquartile range is 29. So 71 minus 42 is a 29. So Q3 is 71. So if any of the values are missing, you can quickly find like that, right? Look here one more time. Q3 minus Q1 is IQR. We don't know Q3. Then that's a 42 equal to 29. Now that becomes fifth grade math. No, third grade math. Something minus 42 is 29. They used to do this, right? Box minus 42 equal to 29. Remember that? In third grade. So just like that, you find that box, that's a 71. Okay, once we have all this, we can now draw the box plot. So let's draw it. First, we start with that line, the beautiful line to show all the data values. And here the data goes from 20 up to 90. You can do that, or you can start with 20, 20, 30, 40. You can do that too. I'll just start with 20 if you don't mind. 20, 30, 40, 50, 60, 70, 80, 90. Okay, there we go. So these are your data values, X. Minimum is 20, maximum goes up to 90. Now, what we need to do is we need to draw a box going from Q1 up to Q3. Q1 is 42, right after 40. So like 42 is there. And then it goes all the way up to 71. 71 there. So that is the box we want. Q1 up to Q3. Q1 is 42 one more time. So here is 40, 42 is somewhere there. And then this is 71 after 70. Then we draw the median at 50. So right above 50, you draw that line, that is the median. You can see here is 50. So right above that, I draw that vertical line. That is the median. Okay, I'm passing this attendance around. Please mark yourself here if you are here. And then 1 second for the students in the Zoom classroom. Let me find your attendance. How do I do that? Okay, there is the link for the attendance. Students in the virtual classroom can now complete it. Okay, now let's draw the whiskers to finish this one. So from the middle of the box on the left side, okay, from the middle of the box on the left side to the minimum value, we draw a whisker. Pretty long whisker now, see? All the way up to there. You can think of a matured cat now, right? Okay. And on this side, we go up to maximum, that's up to 90 from the middle to maximum there. Okay, so we answered the first part of the question, construct the box plot. And here is the second one. What is the percentage of total data between 42 and 71? You know that, look at the screen carefully. You know that this quartiles Q1 and then second quartile median Q3 divides the data into 4 equal parts, 25% each, right? So if you look at the screen here, from maximum, I mean, this is minimum. Why I wrote maximum there? My bad. From minimum, see, from minimum up to Q1, you have a 25% data here. From Q1 up to median, 25%. Median up to Q3, 25%. And Q3 up to maximum, 25%. Here, we want the amount of data between 42 is Q1, up to Q3. So how much data is there? This is 25%, 25%. What is that equal to? 50%. You can also show this in the graph, I mean the box plot if you want. 25, 25, 25 there, 25 there, so that you know that this is 50%. 50% data is between 42 and 71. So that is how you can find those values.